Hello everyone, welcome to NEET Fast Forward. In this small video, we will discuss motion of a body in a vertical circle. So let us suppose that a body is moving in a vertical circle. Say here there is a string, say this is the center of the circle. Here there is a string and say there is a stone tied to the string, and this is being moving in a vertical circle. I call this particular point as the lowest point L. I call this particular point as the highest point H. I name this point as point A. I name this point as point B. Okay. Length of the string, let it be R. Okay. Length of the string is R. Means the radius of the circular path is R. Now when the stone is moving like this, okay. So when the stone is in this orientation, weight of the stone, weight is definitely acting downwards. Okay. If the mass of the stone is m, weight is mg, that is definitely acting downwards. And centrifugal reaction is also acting outwards, because when you are taking a turn in a car, you are being thrown outwards. Okay. The pseudo force centrifugal reaction is acting outwards. So that will be mvl square divided by r. When you look at this at point A, so what is the direction of centrifugal reaction? Direction of centrifugal reaction is this, that is mva square by r. You should carefully observe here. Here I have written vl, here I have written va, because when the stone goes up through the inclined this vertical circle, since the potential energy is increasing, kinetic energy will decrease, and there will be change in speed. Okay, so at different points the speed is different. Then what about the situation here, whether mg is not acting? Okay, mg is acting, but so in this orientation, okay, when the string is like this, mv square by r is pulling the string along the length. Okay, it is pulling the string along the length. What is the direction of mg? Mg is downwards. What mg is doing? Mg is not pulling the string along the length. Okay, tension will be developed in the string only when you pull the string along the length. So mg is not giving contribution to the tension in the string. Okay, so when the particle is at the highest point, okay, the centrifugal reaction is acting outwards, so that is m vh square divided by r, mvh square divided by r. Mg is always acting downwards. Okay. So here, if the body has to move in a vertical circle, what is the minimum condition? Minimum condition is upward force should be greater than downward force. Otherwise, when the particle comes here, then the string will slack and it will fall down. Okay, so let us suppose that you are taking a bucket of water and you are trying to rotate in a vertical circle. When the bucket full of water goes here, and if mg becomes greater, then the water will fall down on your head. Okay, so what is the minimum condition? mvh square by r should be greater than mg. Okay, now we will write the equations for tension in different situations. Okay, and say I'll consider one general point P. Okay, at this general point P, what is the equation of tension? That also I'll write. Say this angle here is theta. Okay, tension at the lowest point, TL is equal to mvl square by r plus mg. Tension at the highest point is equal to mvh square by r minus mg. Tension at point A is equal to tension at point B is equal to mva square by r, because velocity at point A equal to velocity at point B, since they are at equal heights. In any general point, okay, the tension in the string will be mvp square by r plus mg cos theta. Okay, let the particle is here, then what is theta? Theta is 0, cos 0 is 1. So what happens? mvl square by r plus mg will get, since cos theta is 1. Okay, when the particle P is here, theta will be equal to 90 degree, that cos 90 is 0, this mg term will go. when the particle is here, theta is equal to 180 degree and cos 180 is minus 1. Okay, now so what is the minimum condition? We will see. Minimum, if the body has to move in a vertical circle, okay, mvh square by r should be greater than mg, correct? Now see here, outward force should be greater than mg, or at least that should be equal to mg. So this is the minimum condition. Okay, minimum condition. Okay, or minimum condition is mvh minimum whole square by r is equal to mg. What happens? Gets cancelled, so vh square minimum is equal to rg. This r will go here. Okay, vh square minimum equal to rg, or minimum velocity with which a body should have at the highest point. Okay, vh minimum is equal to root rg. What does it mean? When a particle is moving in a vertical circle at this point, okay, if the velocity of the particle is root rg or more, then the particle will successfully complete a vertical circle. So minimum velocity a particle should have at the highest point so that it completes a vertical circle is equal to square root of rg. Similarly, we can calculate the minimum velocity at the lowest point, minimum velocity required at the lowest point, using law of conservation of mechanical energy. Using law of conservation of mechanical energy, what I can write? Kinetic energy at the highest point, or kinetic energy at the lowest point plus potential energy at the lowest point is equal to kinetic energy at the highest point plus potential energy at the highest point. So what happens? Kinetic energy at the lowest point, it will be half mvl square plus potential energy at the lowest point. I'll take it as 0 because I'll take it as reference. Okay, I'll take it as ground, or I'll take it as reference. So here the height is 0, potential energy is 0. Okay, so kinetic energy at the highest point is half m into vh square plus potential energy at the highest point is mg into 2r, because with respect to this reference, what is the height of the highest point? This is r, na? So this is another r, so it is 2r. Okay, so height is 2r. Okay, now m gets cancelled everywhere, and I'll multiply the entire equation by 2. Okay, so what happens? VL square is equal to VH square plus 2g VH square plus 4gr, correct? Now 4gr, 2 into 2, 4gr. So what is VH minimum? I am calculating the minimum velocity. So therefore VL minimum whole square equal to VH minimum whole square. What is VH minimum? VH minimum is square root of Rg. VH minimum whole square means Rg plus 4Rg will be equal to 5Rg, or the minimum velocity that you have to give at the lowest point, VL minimum, is equal to square root of 5Rg, so that the particle completes a vertical circle. Okay. Similarly, I'll use law of conservation of mechanical energy to calculate what is the minimum velocity required at point A and point B. At point L, what is the minimum velocity required? VL minimum to complete a vertical circle equal to square root of 5Rg. VL minimum equal to square root of 5Rg. Okay, VH minimum equal to square root of Rg. So what is the minimum velocity required at point A? We will calculate. Okay, so for that, what to do? Kinetic energy at point A, plus potential energy at point A is equal to kinetic energy at point L, kinetic energy at point L, plus potential energy at point L. So what is kinetic energy at point A? Half m into VA square plus potential energy at point A is mg into R, because you can observe here, with respect to this point L, A is at a height of R. Okay, so mgr, that is equal, kinetic energy at the lowest point is half m into VL square. Potential energy at the lowest point is taken 0 because it is a reference. M gets cancelled everywhere. Multiplying the entire equation by 2. So what happens? VA square plus 2GR equal to VL. What is the minimum value of VL? That is square root of 5GR. Okay, 5RG. Square root of 5RG whole square is 5RG. Okay, so it is 5RG because I am multiplying by 2. So this 2 and this 2 gets cancelled. Square root of 5RG, or VA square, VA minimum square is equal to 3RG, or VA minimum velocity to be given at point A or minimum velocity to be given at point B, both are equal to square root of 3RG. Now I'll write in this main diagram which I have. So VA minimum, okay, VA minimum is equal to square root of 3RG. VB minimum is also equal to square root of 3RG. Okay, yeah. Now we will calculate using this equation of tensions. Okay, we will calculate the minimum tensions in in the string. Okay, so what are the equations of tension? These three are the equations of tensions. Okay, TL. Now what is the minimum value of tension? TL minimum is equal to M by R, correct na? M by R into VL minimum whole square. What is VL minimum? VL minimum is square root of 5RG whole square is 5RG plus mg. So what happens? So R and R gets cancelled. 5mg plus mg will be 6mg. Minimum tension that should be there in the string at the lowest point in order to complete a vertical circle is 6mg. Okay, so TL minimum is 6mg. So similarly you can calculate TH minimum is equal to M by R into VH minimum whole square. Square root of RG whole square is RG minus mg. That R and R gets cancelled. Mg minus mg will be equal to 0. Minimum, okay, at the highest point minimum tension can be 0. Okay, and what is the minimum tension at point A and point B? Minimum tension at point A or point B is equal to, so here MVA square by R. So M by R into VA minimum is square root of 3RG whole square. 3RG, R gets cancelled, is 3mg. So minimum tension at the lowest point is 6mg. Minimum tension at the highest point is 0. Minimum tension at the point A and point B equal to 3mg. Always we should remember difference between tension at the lowest point and tension at the highest point. It should be 6mg. Okay, you can also remember these things like this. See here in the main diagram, minimum tension, okay, minimum velocity to be given at the lowest point so that the particle completes the vertical circle is square root of 5rg. At point A it is square root of 3rg. At point H it is square root of rg. So by a factor of root 2 the velocity changes. Square root of 5rg minus square root of 2rg is square root of 3rg. Square root of 3rg minus square root of 2rg is square root of rg. For every 90 degree velocity increases by a factor of velocity changes by a factor of root 2 rg. So here if the tension is 0, when you come down here, the tension should be plus 3 mg. It is 3 mg. Minimum tension at point A is 3 mg. When you come here, the minimum tension is 6 mg. Okay. If the tension here is 6 mg, then the tension here will be 9 mg. Tension here should be 12 mg. For every 90 degree, tension should increase by a factor of 3 mg, and velocity should increase by a factor of root 2 rg. Here you remember this, square root of root rg, then it is square root of 3 rg plus 2. You have added 2. It is 1 rg, this is 3 rg, this is 5 rg here. Okay. Yeah. Thank you very much.